Hello everyone, welcome to the design of a buck converter. In the previous video, I have uploaded the design details, how to calculate the value of inductor, capacitor, everything I have included there. This is the problem statement. Design a buck converter with the following specification. Input voltage is 200. Output voltage varied from 50 volt to 150 volt. Load resistance is 20 ohm. Ripple in the inductor current is a 20%. Ripple in the output voltage is a 5%. Switching frequency is a 50 kilohertz. So these are my design requirement. So let us see how we can design this circuit. So first we will need okay, so what type of circuits we have to plot for this. So let me copy the circuit from my Visio file. Okay, wait, I will copy the circuit from my Visio file. Okay, so let me reduce this size. Okay, I have to design this circuit in MATLAB with the input voltage of 200 volt and with this given specification which I have uploaded in the previous video. So I need a DC voltage source. So type the DC voltage source. I will get a DC voltage source here. Double click on that. I need the voltage is of 200 volt. Hmm. Then I need a series RLC resistance as a load. So series RLC branch, I will take it as a load. Control R, then it will rotate. The value I need only resistance here. The resistance is of 20 ohm. Apply. Okay, so this is my load resistance. Now, again, I need a series RLC branch. Okay, series RLC branch. From here, I need one inductor. So I need only L, that is the inductor. Inductor is 6 millihenry, that is 6 e raised to minus 3. 6 millihenry inductor is needed. Then I need one uh, capacitor. So again, I will type a series RLC branch, rotate it, and I need a capacitance which is connected across the load. So I need the value of capacitance. Capacitance is 15 microfarad, that is 15 e raised to minus 6. E means 10, 10 raised to minus 6. Now I want the switch. So I'm going to use a MOSFET as a switch. So type the MOSFET used from the specialized power electronic library MOSFET. Okay, so this is the MOSFET which is to be connected here. The source terminal will be connected here, and the drain terminal will be connected to source. That is source voltage. Now, this MOSFET, in this MOSFET, I don't need the measurement block, so I will disconnect. We'll keep all other elements as it is. So apply. Okay. So I want to give the gate pulse here. So take a block of from. Okay. So from I will connect one gate pulse over here. So gate pulse we will generate externally. Okay. Gate pulse, or I will simply give the name G for a gate pulse. A tag will be updated at the latter moment. This side I will connect in the circuit. Mm. Here it is to be connected. Here it is to be connected. I need one freewheeling diode is also required over here. So freewheeling diode must be connected here. So type diode, rotated. It should be in anti-parallel. That is cathode terminal is on upward side and anode terminal is on downward side. I don't need the measurement port. So measurement port, uh, I will deselect it, the measurement port. So I have prepared the power circuit. Now I need to add the measurement. So take the block of voltage measurement. So this voltage measurement, I want to measure the output voltage. So I will connect across this output voltage. Okay. And here I will connect the block of go to. will connect this go to block here. Name to this go to block is V0 as it is going to measure the output voltage. Make it global variable, apply, OK. Now I want to measure the induct current through the inductor also. So I will transfer this circuit. Here I will disconnect this and I want to add the current measurement block. So I will take the current measurement block. Okay. And again I will copy this go to block from here. Wait. So go to block. I will connect this block here and rename this as the I0, or you can rename it as IL also because it is the inductor current I0 or IL. You can mention anything there. Now this is my source voltage, so I can give this name as Vs. This is the source voltage. So I want to give the gate pulse now. So this is the power circuit which I have designed. So take the area. I will press this area here. I will copy. I will merge this in this area, and on question mark I will type buck converter. This is what power circuit. Hmm. Now we need the controller. So we want to design a controller. So controller voltage must be varied from 150 50 volt to 150 volt. So we'll take a block of constant. Sorry. Okay, we'll take a block of constant. In this constant block, first I will set the voltage to the 50 volt. Then take the block of add 50 volt and the actual output voltage. So I will take the block of from the actual output voltage and 50 volt, it must be subtracted. That is, first sign is plus, second sign is minus. So actual voltage V0 is subtracted, so error signal will be generated over here. You click on update tags, apply, OK. So I have not saved this circuit, so first I will save it. Okay, I will give the name buck. Now this error signal is must be given to the PI controller. So take the PI controller, connect this PI controller block here. I will keep this gain as open this. I need only PI controller, so choose PI, and proportional gain I will keep it on 1800 and integral gain I will keep it on 300. So for my circuit it is working best because I have simulated it earlier. Otherwise you have to use the trial and error method for this. Okay, this is the PI controller output you will get. Now it must be compared with the triangular pulse. So how to generate the triangular pulse? Take the repeating sequence block. Okay, in this repeating sequence block, what is the switching frequency I need? First is at 0, second switching frequency 50 kilohertz. So 50 kilohertz, how will convert it into time? It is 1 upon frequency. That is 1 divided by 50 e raised to 3. It is my value of the time. At that instant, my output should be 1. So at a 0, output is 0. At 1, output will be 1 at 50, 1 upon 50 kilohertz. So that is 2.2 10 raised to minus 5 second. The output is equal to 1. So it will generate a switching pulse of 50 kilohertz. Apply. Okay. The second thing you can do like this also. 0 uh, then 250 we can divide into three parts, 0 1 0. Likewise also you can repeat, but need not to do in this type of circuit. So this PI controller output, it must be compared. Now we will take the logical operator over here. Sorry, not a logical operator, relational operator. Relational operator. Okay, and this relational operator I will change to greater than or equal to. Okay, greater than or equal to means your PI output, if it is greater than this repeated sequence, then the pulse will be high, otherwise the pulse will be low. So this is, I will connect go to block, and this is my gate signal generation. So here I'm generating the gate. So gate signal is denoted by G. So I will type it G. Once I type the G, the corresponding block is get highlighted. It means it is connected to this G block. Make it global variable. Apply. Okay. So this is what my controller design. So I will copy in this another area, controller. Now we want to see the measurement. So I want to see the measurement. So measurement, what I want, output voltage and output current I want in the measurement. So take the block of from, double click on this, make it V0, apply, okay. Similar way, I will drag it downside, I0. I need the source voltage also because to calculate the duty cycle. So I will take the one voltmeter from, okay, sorry. I will copy the same voltmeter here, mm, rotate it, but see, plus is on downward side, minus is on upward side. Make it the sign changes by using the format, go to flip block and press up down. So plus sign will appear up and downside will appear, negative will be appear on downside. So this is a negative, and connect the block of go to again. Okay, so this go to block I will connect here, and what is this? This is my source voltage. So I will give this name as a VS. So VS, V0 by VS is nothing but, so I will take the block of from here, the value which I want is a Vs. Okay. We know that V0 upon Vs is the duty cycle. So let's make this variable as a global. Okay, global. Then I will take this divide one because I want the duty cycle. So output voltage divided by input voltage is my duty cycle. So it will calculate the duty cycle. Then I will take scope. Okay, so better way we'll take the current on downside. So Vs Is, and here what we will do, we will increase the scope path. Okay, so we'll increase the number of axes in the scope. Go in the setting, set number of axes is equal to 4. Apply. Okay. So and uh, choose the layout as like this. Okay, so the 4 axis will be created here. Increase the size of scope. First connect the source voltage, then connect the output voltage, then connect the duty cycle, and then connect the output current. So let us come here. This is what my source voltage. This is load voltage or output voltage, you can say. Here it is duty cycle, and here the current is output or load current. Load current. So this is all about the measurements block we have connected. Now let us copy. This is another area. If you create the area, it circuit looks good, and it is very easy to access also. In this, we have added all types of measurements. Okay. Now, to simulate this, we need a Power GUI block. So, Power GUI, you choose the Power GUI, sorry, not the Power block, Power GUI, Power GUI. Keep it on continuous mode only. So, keep the mode continuous. Now, you change the solver over here. You choose the solver from this as 23T, 23T solver, 23T solver. Now, let us simulate for zero point 0.1 second. Okay, let us simulate for zero point 0.1 second. So stop time I'm changing to the 0.1 second. Okay, now let us run this circuit. Okay, as you can see, the simulation is slower at this moment. So what we will do, I will stop the simulation. Let's save it. Instead of 23T, we will choose another solver. Okay, so let us choose the 23TB solver and run it. So now the circuit is running faster. Okay, everything is simulated. Now see, source voltage is 200. The output voltage required is 50 volt. At that time, the duty cycle is 0.25 and the current is equal to 2.5 ampere. You can zoom to any of this and you can check. See, this is my output voltage. Little bit variations, otherwise output voltage is constant to the 50 volt. Duty cycle, if I check, duty cycle is almost 0.25. Load current, if you check, the load current is just 2.5 ampere. Okay, so it is nearby 2.5 ampere, which is calculated value 1. So this is about when the it is for 50 volt. Now make it is equal to 150 volt. Make it is equal to 150 volt. Run it again. Okay, and just click on scope. So you can observe here the voltage is again becoming 150 volt. The duty cycle is changed to 0.75. The current is 7.5 ampere. Okay, you can export this figure by using uh, print to figure. I will show that it again to you, print to figure, how to work with the print to figure. Hmm. So, but for this now we have calculated this. But suppose I want the variation from 50 volt to 150 volt step change I need. So what I will do, I will take this step input over here. I will connect this step input instead of constant block to this reference value. Okay, so reference is connected to the step. The step time, okay, so step time first, I'm going to switch over my circuit at 0.5 second, sorry, 0.05 second. Initial voltage is 50 volt and final voltage I need a 150 volt. Okay, so this is the switching I'm giving. So if I run this, you will observe that, see, up at 0.05, the voltage is switched over from 50 volt to 150 volt. Current is also switched over and voltage. Similarly, you can check it for any voltage. Suppose I need in opposite manner. So initial voltage is 150, but final voltage I required a 50. Okay, so you can check 150 to 50 changeover is there. So see, this much are the transients in my circuit. Okay, so this is what the settling time almost it is from zero point 0.5 to 0.15 matlab 0.0015, that is 1.5 millisecond is my settling time of the circuit. Okay, so I need this, I want to export this figure. So how to export this figure? So first what I will do, I will go in the setting, display, sorry, not on this. Okay, right click to, or here there may be the button of style. Okay, style, click on style. Okay, this will appear. Make the figure color white, access color, access color keep it black, then apply. See, access color is still black, but if you want to make it white, apply. Okay, so now everything is white. If you need the this all with the black color, then you click on black color. So first figure is black. Then in this figure again, okay, so let us zoom out this, view, style. In the second plot, I need again a black color, or okay, so just a minute. I'm not able to visualize this graph. Okay, or you can go into the print to figure. Here in print to figure, you can edit everything. You click on tools, view, property editor. It will open the property editor block. Okay, so if I click this on yellow plot here, I can change its width to 2, color to black, width is changed to 2, color is black. Similarly, in this plot also, I can change this yellow color to black. This width is to 2. In this block also, I can change this width is 2, color is black. Click on axis. You can change the font of axis, but I can change the font of axis directly from the another, that is export. Okay, so from the export block, go to the export setup. In this export setup, you come on rendering, then font. In this font, you fix the font size to 14. Okay, apply to figure. Everything size will be to the 14. Then you can change this font color. I think color option is not available here. Lines, if you want to change this line with the fixed line length, then you can change this fixed line length to 2. Apply to figure, so everything is changed with this line. Now you can double click on this. I want to change its color. Okay, so not getting where is exactly that. Okay, so go in the view, again property editor. You can click on this axis, uh, font. Here we can change the color as black. Okay, we can change the color as black. This figure color is white. On y-axis, I can change the color as black. See, this color is changed to black. Now here also I can change this color as a black. Here also I can change this color as a black. This color also as a black. So by this way you can edit the plot as you want. Okay, so this is the my entire so source voltage, load voltage, duty cycle, and the load current. Hope you understand this video. Uh, if you like this video, kindly subscribe my channel, share with your friends. So this is of design of a buck converter with the given specifications. So you can design for your own specifications also. Thank you.